ball valves. Yes, Kuhan, you have a question? Hello?
Sure.
Yes? You have a question?
Sir, can you please repeat back the last section just before the ball valves?
Was it going too fast? I apologize then. Okay, so here we're looking at the distribution block itself. It is just a design drawing or 3D drawing, so we can see what's going on inside the piece of metal. It is a series of ports, bores, and channels for the transfer of hydraulic pressure oil to and from the end users. So we have this for the booster, this for your exhaust actuator. This is where your fever will be placed in this design. We have a series of ball valves here. We have an accumulator mounted here and the ME lubricator in this design mounted here. Another accumulator mounted here. And here we have this double wall pipe. No, sorry, overflow pipe. Okay. Was that clear, Kuhan?
It's clear.
Good. So we can see that we have the plugs. These plug screws, they are, of course, to plug the ports, and they have a seal ring, a backup ring. So these also have to be changed every now and again. So as you're doing your rounds, even though we forget the pressures that are running through the system, sometimes we need to ensure that they are not seeping or leaking. And if they are, then you need to monitor them. I wouldn't recommend tightening them up. You probably end up causing more damage. So you need to ensure that you get something done almost immediately, just in case something happens. Okay, cool. We're looking at the design drawing of the distribution block itself with the components mounted on it. Here we can see that we have our fuel booster with the feedback sensor we talked through yesterday, going through the calibration so we know the position of our plunger inside. We have our exhaust valve actuator, minus, of course, the push rod. We have this overflow pipe or deaerating point. This is the highest point in the system. So we have a constant flow of oil under pressure. So we are constantly releasing any possible air buildup, air bubbles in the system during pressurization. Then we can see we have the fever, the fuel injection valve, activation valve. We'll have a look at that in more detail tomorrow, but we're going to talk through the function of it today. We have the ME lubricator. We're going to have a look at that this afternoon, or later on, sorry. And the accumulator itself, 1, 2, or 3, depending on the design and the placement. You will have accumulators on your system. I'll also have a look at that a little bit later. Here we can see we have a ball valve. There are other ball valves, and depending on your engine size and design, depends on the placement of these equipment here. The booster is always on the left and the accumulator is always on the right. The other components, they may vary where they are situated, but I will guarantee that you'll have your fever, your accumulators, your lubricators, and of course your ball valves. The standpipes we'll see here, these telltales, these are an indication for the connectors, I apologize, gents. The seals on the mating surfaces of components on your hydraulic cylinder unit block, so the distribution block. So one of them will be for the mating surface or the seals or gaskets between the booster and the distribution block. One of them will be for the gasket or seal ring for the exhaust valve actuator, and another one will be for your ME lubricator. The accumulator, when we have a little bit closer look afterwards, we will see that on this connection flange here, there are 4 screws on the underside At the closest point in the center, so between the block and this flange, you'll have also a telltale. So if there's any oil and it won't run out or flush out, it will just drip, then that's also an indication that you'll need to change the seals on here. So if you need to change any of the seals or gaskets due to the telltale, then you might as well overhaul the entire unit. Therefore, you then know that that unit has X amount of running hours back on it. Okay, gentlemen? Are there any questions to that? No? Okay. Here we can see the Trinidad system, and I'll try and zoom in as best I can. We'll have to take this part here. So everyone can see this drawing?
Yes, we can see the drawing.
There's a question from somebody,
Yes.
window.
If there's no leak, the running hours that you need to overhaul the unit, the overhaul times are stated in the service letters from MAN, and depending on the unit that we're talking about, depends on what overhaul times that we're looking at. I don't have the service letter in front of me, but I can find the service letter title for you guys, and you can also find it on the MAN website, the PrimeServe website as well. But we'll get through. I'll find it for you at the next break so you can see what we're talking about. Okay. So here, looking at the drawing, we can see that we have the exhaust valve, the exhaust valve actuator, we have the fuel oil pressure booster and the slide fuel valves. We have the fever in an exploded view. So inside we can see this main spool, and we have a pilot valve for the control or movement of the main spool. We also have accumulators on the system. We have a series of ball valves. We have a series of mini mesh connections. Okay. The red line is our high pressure line. The blue line is our low pressure line, and the pink line is our atmospheric or internal leakage line. So of course we have to have a combination of the high pressure and internal leakages, or else we would just lock the system. So we can also see that we have a series of ball valves shown here. The ones in the green circle, these are normally closed, and the ones in the orange circle, these are normally open. The 531 is a valve on your low pressure line. The other valves should appear on the hydraulic tune unit. Okay, an easy way to find out or remember that if it ends in a 0, it has to be open during normal running. So O for open. 420 is our main supply. 421 is our main drain. And 405, 406, these are our drain lines for the fever valve itself. So we're going to go through a working description of the fever in steps. So of course, as we know, when the engine is running, we have a fluid movement. So what we're looking at here, we have pressure coming in through valve 420, charging our accumulators, and then we're going in to the fever valve itself. And then we have on the injection side, we have control oil pressure. On the exhaust side, we have constant oil pressure. And in the center of our fever valve, we have working pressure. Okay, so control oil, working oil, and constant oil pressure. Okay. We have some channels or ports inside the fever, so we are able to supply pressurized oil to the underside of the booster or to the underside of our exhaust valve actuator. Never at the same time, because we're either only injecting or we're doing an exhaust valve operation.